High in the winter sky, marking the right shoulder of the celestial hunter Orion, glows a fiery red jewel. Betelgeuse. Its name is a whisper from the past, a corruption of the Arabic Yad al-Jawza, meaning the hand of Orion. For centuries, this star has captivated observers, but today it holds our attention for a more dramatic reason. Betelgeuse is a red supergiant, a star nearing the end of its life, and one of the closest to our solar system, giving us a front-row seat to a spectacular cosmic finale. As a red supergiant, Betelgeuse has a relatively cool surface, giving it its distinct reddish-orange hue, but what it lacks in heat, it makes up for in sheer, mind-boggling size. If we were to swap our Sun with Betelgeuse, its surface would extend past the orbits of Mercury, Venus, Earth, and Mars, reaching towards Jupiter. It's a celestial behemoth, packing the mass of nearly 20 suns into a volume 1 billion times larger than our own star. This immense mass makes it burn incredibly bright, shining with the light of over 100,000 suns, making it a luminous beacon in our night sky. Located roughly 650 light-years away, Betelgeuse's brilliance usually makes it one of the top 10 brightest stars visible from Earth. But recently, Betelgeuse started acting strangely. In late 2019, astronomers watched as the star began to dim dramatically, an event dubbed the Great Dimming. It sparked a global frenzy of speculation. Was the supergiant about to explode? Scientists now believe the dimming was caused by the star itself ejecting a huge bubble of hot gas, which then cooled into a vast cloud of dust, temporarily obscuring its light. It was a stellar sneeze of epic proportions, a reminder of how volatile this star truly is. To understand why Betelgeuse is on the verge of collapse, we have to look at its life story, a life lived in the fast lane. Stars like our Sun burn their fuel for billions of years, but massive stars like Betelgeuse live fast and die young. For about 8 to 10 million years, it furiously fused hydrogen into helium in its core. This process generates immense energy, creating an outward pressure that holds the crushing force of gravity at bay. But a massive star's fuel tank empties quickly. Once the hydrogen in the core was exhausted, gravity began to win, compressing the core and raising its temperature. This ignited new rounds of fusion and caused the star's outer layers to swell enormously, transforming it into the red supergiant we see today. Inside this bloated giant, a frantic, multi-layered fusion factory is at work. In a structure like a cosmic onion, shells of different elements fuse around the core, helium into carbon, carbon into neon, and so on, creating heavier elements. Each stage happens faster than the last, a desperate attempt to stave off gravity's final victory. The final product of this chain is iron, and iron is a dead end. Fusing elements up to iron releases energy, but fusing iron it. When the core of Betelgeuse becomes solid iron, the furnace will shut down for good. In that instant, the outward pressure will vanish, and gravity will win. The core will collapse in less than a second, triggering a titanic rebound shockwave that will tear the star apart in a Type II supernova. This is the fate that awaits Betelgeuse. It could happen tomorrow or 100,000 years from now. But when it does, it will briefly outshine the full moon, a spectacular new star visible in broad daylight. Something very interesting has been going on with Betelgeuse. You may have heard this year that Betelgeuse has been dimming, and scientists didn't really know why. New data from Hubble has shown the star may not be dimming, but rather dust ejected by the star has cooled and obscured our view. In September 2019, Hubble saw heated material moving away from the star's atmosphere. As it moved around the star, it expanded and cooled, crossing over our view of Betelgeuse. Imagine looking up at a familiar patch of sky, only to see a brilliant new star staring back. That's what happened to amateur astronomer John Birmingham in Ireland in May 1866. He glanced at the C-shaped pattern of the Northern Crown constellation, Corona Borealis, and was stopped in his tracks. A star that wasn't there before was now blazing brightly. But Birmingham wasn't the first to witness this celestial phantom. Centuries earlier, in 1217, a German abbot named Burchard of Augsburg noted in his chronicles a faint star that for a time shone with great light. For over 600 years it remained dormant, a secret waiting in the dark until its spectacular reappearance. So what is this blaze star officially, T. Coronae Borealis? It isn't a single star, but a volatile cosmic couple. The system consists of a massive red giant and a tiny, incredibly dense white dwarf. The red giant is an aging star that has swelled to enormous proportions, its outer hydrogen layers held only loosely. Its partner, the white dwarf, is the collapsed core of a sun-like star, no larger than Earth, but packing the mass of our sun into that tiny volume. Its immense gravity acts like a cosmic vampire, relentlessly siphoning hydrogen from the red giant. This stolen gas doesn't fall directly onto the white dwarf. Instead, it spirals inward, forming a vast structure called an accretion disk, a swirling platter of superheated material that glows intensely. For decades, this process continues. Layer upon layer of hydrogen piles up on the white dwarf's surface. As the layer grows thicker, the pressure and temperature at its base build to unimaginable levels. Finally, a critical point is reached. At 10 million degrees Celsius, the hydrogen ignites in a runaway thermonuclear reaction. This isn't an explosion that destroys the star, like a supernova. It's a colossal surface-level detonation that violently blasts the accumulated material into space at thousands of kilometers per second. This sudden, cataclysmic release of energy is what we see as a nova. When this happened in 1866, astronomers like Sir William Huggins used early spectroscopes to analyze the light, discovering it was rich in glowing hydrogen, confirming for the first time that these events were titanic stellar explosions. The result is a dramatic brightening, making the star system shine with the light of hundreds of suns. And now, after another 78-year wait, the stage is set for an encore. Sometime in 2024, T Coronae Borealis is predicted to erupt again, offering us a rare front-row seat to one of the cosmos's most spectacular shows. This is a genuine once-in-a-generation opportunity. To find it, you won't need a powerful telescope, just your own eyes and a clear, dark sky. Locate the Big Dipper, then follow the arc of its handle to the bright orange star Arcturus. Look to the east for the brilliant blue-white star Vega. Between these two celestial beacons lies the faint, C-shaped circlet of stars known as Corona Borealis, the northern crown. Normally, T Coronae Borealis is far too dim to see, but when the nova ignites, it will surge to a magnitude of 2 or 3, making it as bright as Polaris, the North Star, and instantly adding a brilliant new jewel to the crown. But you'll have to be quick. This stellar show is incredibly fleeting. Once the blaze star erupts, it will likely remain visible to the naked eye for only a few days, maybe a week, before it begins its rapid fade back into obscurity. It will vanish from our sight as quickly as it appeared, returning to a faint glimmer only visible through large telescopes. As the ejected shell of gas expands and cools, the star system settles down, and the long, slow process begins all over again, setting the stage for the next eruption in another 80 years. So keep your eyes on the northern crown. You might just witness this ghost star blaze back to life. The night sky can seem eternal, a silent, static backdrop. But this is an illusion. The cosmos is a dynamic place, and events like novae remind us of this powerful truth. A classical nova occurs in a binary star system where a dense white dwarf siphons hydrogen from its larger companion. This stolen material builds on the surface until it ignites a runaway thermonuclear reaction. The star doesn't destroy itself, but it violently ejects its outer layers in a brilliant temporary flash, a true cosmic fireworks show. For astronomers, each nova is a treasure trove. By tracking its brightness over time, they create a light curve that reveals the physics of the blast. Using spectroscopy, they can identify the chemical elements forged and ejected into space. This data is crucial. It helps us refine our models of stellar evolution and shows us how stars seed the cosmos with the heavy elements necessary for planets and life. We are, in a very real sense, made of stardust. But novae are just one type of stellar drama. For an even bigger show, we look to stars on the verge of complete self-destruction, like the unmistakable red supergiant Betelgeuse in the shoulder of Orion. This behemoth is nearing the end of its life. If it replaced our sun, it would swallow the inner planets. Recently, its great dimming event, where it faded dramatically, reminded us it's a ticking time bomb. Scientists believe the star ejected a massive cloud of dust that temporarily blocked its light, a cosmic sneeze previewing its coming demise. When it finally goes supernova, Perhaps tomorrow, perhaps in 100,000 years, it will blaze in our sky brighter than the full moon, visible even in daylight. It's a safe distance away, posing no threat, but offering a spectacular, once-in-a-civilization event. So next time you find Orion, look at that reddish star and appreciate that you're seeing a star on the edge of oblivion. It's a profound connection to the grand cycles of the universe and a powerful reminder of how lucky we are to be here, looking up in wonder.